I am Mike Smith. We've got, what do we got here? We got 15 folks. Okay. Yes, Mike is presenting more. Some of you might have seen me in a workshop I gave yesterday that was a good 4 hours of talking, and I ran out of steam after 4 hours. But this is quick, it's short, but it's also what I do in my day job. Yes, I know, Michael Ortiz, 4 hours wasn't enough. Yes, I know that. Sorry, we can pick this up later. Michael went crazy. I don't think he slept last night. He was decoding pagers. This presentation itself is what I do in my day job. Okay, so let me give it a couple minutes here, but in my day job, I'm a field CTO for Neustar Security Services. Really, I handle DNS, DDoS mitigation, cloud web application firewall, cloud bot management. Okay, and really, my job is kind of fun. I get to help pretty much everybody make them smarter. Okay, so whether it's product management, so I sit inside of product management, help folks out there. I'm the wise old man who has experience and stuff. I just act like I'm 12. I help my sales folks understand like use cases for our products, customer concerns. I translate sometimes when people are like, oh, well, what about this and this and this? And it makes no sense to anybody. I translate it. I also help on the operations side, some cyber threat intelligence. I've got Richard here. He works for me. But a bunch of different things. I just, pick up where there's a gap and then try to fill that gap. Okay. So this is my day job. Let me get into this thing. All right. So this is not a pitch. I'm going to try to keep pitching to a minimum. I might have to talk about things just because it's tied to my experience. But as a company, what my company does is we are a large infrastructure provider. Okay. And we started out a good 14 years ago. We had a DNS platform, both authoritative and recursive or resolver. And we operate that, and we actually operate some of the top levels. I mean, it's really, really cool. Then we built a DDoS mitigation scrubber, and I'll talk a little bit about those inside this presentation. And we have a relatively nascent, we're getting some traction on it, but we have a CloudWAF. And all of these I'll actually talk about directly and indirectly, plus other methods of dealing with DDoS and DDoS mitigation. So there's me, boom. Relevant to our scope of conversation here, I've been studying DDoS since 2008 when the Anonymous decided that they were going to launch DDoS attacks against the Church of Scientology. So I started, downloading tools, seeing what they did, doing a lot of tools, players, research in that. Then in 2010, I started working for a company, small internet startup called Akamai. I worked there for a good 10 years. But in 2010, there was all of the hacktivist attacks against PayPal, eBay, Visa, U.S. Senate. These are all public records, so it's not like I'm outing anybody. But all of these just hacktivist DDoS attacks around support for Julian Assange, okay, and WikiLeaks. I was the incident manager, so I basically fought hacktivists for a week. Absolutely fantastic experience, but it's also it's brutal. It's brutal. It's incident response. But I was the incident manager for that. Then in 2012, because of the DDoS attacks on U.S. banks, and that's what we call Operation Abobble, or that's what the attackers called Operation Abobble. We formed an incident response team, and I was the founder and director of that. So I taught the rest of the company how to fight DDoS. Okay. And I've been doing that on and off. Akamai bought a company called Prolexic. That was a DDoS scrubber. They had a CloudWAF. They had a CDN. They had a large DNS infrastructure. Today at New Star Security Services, I've got similar tech stack, large, massively scaled infrastructure that we have to defend, right? So we have to protect ourselves, and we sell products that our customers use to protect themselves, right? So it's kind of this, like, we protect ourselves, but we also protect everybody else. So that gives me this weird amount of insight on distributed denial of service. What is it? What works? What doesn't work? I've seen lots of proof of failures. I've seen some successes. I've seen lots of good stuff happening. I took all that and rolled it into this presentation. Okay. One of the most fascinating things for me is in this space is every DDoS mitigation provider out there will give you marketing slides. And the marketing slides always have attacks are ever increasing. Yes, they are. And they're ever increasing because of just economics and scale. And really, the size of the largest DDoS is growing, right? And it continues to grow. I remember back when people said, oh, well, DDoS will never reach a terabit. And now it's multiple terabits per second, right? So that the maximum size of DDoS is increasing because bandwidth is getting faster. The attackers have more bandwidth to throw at the target. They're also becoming more and more frequent because of just different frequency different techniques for launching attacks, different ability to build a platform to launch attacks. I worked a little bit around the Mirai botnet back in 2016, where they compromised a bunch of cameras, internet-connected cameras that had multiple layers of vulnerabilities that were then chained together to build a platform to attack things. Right, so I did that. Operation Ababel was built, or the botnet, which was called Brobot, because it had a status message that was, it's okay, no problem, bro. That Brobot was built of compromised WordPress and Joomla installations where the attackers put their own, similar to a PHP web script. So they built a platform that way. Sometimes the attackers will use malware to infect desktops to stick those together. But basically, as the bandwidth to the endpoint or even to the data center has increased, the maximum size and the frequency of attacks has continued to increase. The other thing that's absolutely fascinating for me, and that really changes my strategy and what I recommend to people, is that DDoS attacks have a cyclic nature. You will have 12 months or 24 months where none of your peers are getting attacked, unless you're in finance or gambling. If you're in gambling, you get DDoS all the time. If you're in video games, online gaming, the non-adult online gaming, you get DDoS all the time. Everybody else, it comes in these just like 2-year cycles where none of your peers get attacked. And so you're like, well, we've got this solution that's here for a value solution, and we haven't used it in the past 12 months. So do we really want to renew our contract? Right? And then all of a sudden, all of your peers are getting attacked, and you're like, we got to get this together. And what happens in that period of time, at one place that I worked, they called it peacetime, and I just kind of vomited all over that for various reasons. But during that kind of downtime, when it's a lull in the cycle, operations staff rotate out of positions. You don't renew your service provider contacts. Your user population grows and you don't scale up correspondingly with it to have that extra capacity. And so, and you don't test, right? It's DDoS is a high impact, low frequency event. So the first time you turn stuff on, it's always sort of a little bit of a crapshoot. Like, hey, is this going to work? I don't know. Let's go test it. Right. So testing has a huge amount of value here. Here's your marketing slide with graphs. Trends over the past couple of years. Number one, carpet bomb attacks, where the attackers rotate. They target one IP address, then another IP address, then another IP address, then another IP address, in order to get around some technical controls. Okay, where you have a lot of DDoS mitigations, they'll do sampling. So they have a sample period of something like 5 minutes, and then they switch to mitigation mode where they start blocking things. So if you can change your target or your source or the technique that you're using, and if you can change that faster than that sample period, by the time the mitigation technology goes to block that traffic, you've already changed and you're evading that particular block that they put there. So we're seeing more and more of these carpet bombing attacks, just where they just roll through all of the different targets that they could roll through. Ransom DDoS has been around a long time. It's racketeering, right? And that is increasing, believe it or not. So we first started seeing these pretty heavy back in 2010. It still has increased. There was a period in 2016, 2017, where it wasn't really attackers. It was just people who used the name of a known attacker and sent out notifications to see who would pay up. But similar to ransomware, where they demand that you pay them in Bitcoin, exactly the same thing with ransom DDoS. Okay. Attackers are targeting DNS, and you do have, I've got a lot of customers that have the cost of downtime is measured in how many transactions they have per minute, per hour, per day, and then what's the total dollar size of those transactions. Okay. So the longer that DDoS lasts, the longer the outage lasts, the more expensive that it is to mitigate that DDoS. And really, that's what DDoS is about. It's about economics, and you have a solution that has a particular cost, but the scale of that solution means a higher cost. And it's really, you're trying to figure out how to balance that cost with the level of protection that you get. Okay. I built a white paper. That white paper lists 6 different technologies / architectures that people use to protect against or to mitigate DDoS. I'm going to go through all of these one by one, what the positives are, what the negatives are. If you want the white paper, just message me. I'll give it to you, or hit up our website and you can grab it. Okay. One interesting thing with DDoS, which is that you don't solve DDoS, you mitigate the impact of the DDoS, and eventually the attackers go away. You don't actually fix the problem unless you go out and figure out how to take apart their platform that they're using to attack, or if they're leveraging vulnerabilities, you get rid of those vulnerabilities, or configurations or misconfigurations. And that's what we did a lot of with Brobot, with Mirai, with DNS amplification attacks, is we started to identify the platforms that were used for DDoS attacks, and we started to take them apart. So that way we did denial of a platform to the attackers. Okay. First technique or technology architecture that people use is going to be over provisioning. So back in the old days, you would run your network, and your servers and everything at about 80% utilization. Okay? So you'd leave that 20% headroom. Maybe you have a good marketing event. A lot of people show up at your website. Maybe maybe COVID happens and now you've got more VPN users. But you would keep that 20% reserve capacity. So a lot of people nowadays have switched to using 60% utilization. So they'll keep 40% as reserve capacity. Okay? And there are different ways you can do that. If you're hosting your applications and services, you buy more kit, you buy more bandwidth, or more circuits, you buy more firewalls, you buy more servers, you buy more licenses to applications, you buy more database. But typically from the web server, network devices, and bandwidth from your provider, right? If you're a small guy, you're a small organization, small website, this is probably going to be about all you can afford, okay? With an exception of a free cloud service, and we'll get there, right? And the reason why is because it's any other bigger solution is just not cost effective, right? And you might even realize that yes, you might even realize that yes, if I get a big attack, it's just not cost effective to protect against it. So I'm going to go into DNS and change my DNS records to black hole the traffic by changing that A record to a loopback address. So 127.0.0.1, boom, make the attack traffic go away. And yes, my website goes away, but that's okay. And I wait for the attack to die. And then I go in and set it back up. Okay. What's funny to me is that over provisioning works on the smaller website operator side. It also works on the large website operator side, where they will go in and have a lot more capacity, simply because, well, they also are worried about spikes in user traffic. Okay. Also folks that are growing, right? So they're growing and they know that, well, they just want to buy that capacity anyway, because if they give it 12 months, they'll have to add more capacity. And so they just keep kind of, adding to their stack as they go. That's it for over provisioning. There is one thing I didn't mention, which is a lot of folks will go to cloud providers and they will get like an IaaS cloud provider, and they'll stand up server instances and then use auto scaling or some other kind of orchestration so that when they have a bigger demand on their services, they will grow the amount of servers that they have using auto scaling. Okay, so that's also a possibility out there. It gets costly, but it's a possibility. Now, the positive side, a lot of DDoS attacks are smaller attacks, right? The mean by far is like 5 gigabits per second, but you'll see a lot of attacks that are 1 gigabit per second or less. It's very easy to, if you have extra capacity, you say you have a big data center, you have a couple 10 gigabit per second circuits coming into it. Yeah, it's very conceivable that you could absorb and defend against a smaller DDoS like that. They're extremely common, especially if you have some edge kit that also has DDoS mitigation capabilities, right? So you might have routers that allow you to put ACLs there. You might have firewalls that have storm congestion, right? You might have all of these different features that are built into your network devices that you could turn on that gives you a certain level of mitigation, okay? The minuses here, the minuses to anything that we call on-premises, right, or inside of your data center or even inside of a cloud, is that your capacity is limited, right? So you're limited in bandwidth, servers, network capacity, all of that stuff. You have a limitation in those. And so at some point you hit that gap and you're over capacity. And it doesn't really matter if you're 1 megabit over capacity or you're 1 terabit over capacity. You're over capacity and you have an outage. Okay. The other one is you run into this thing where you spend a lot of cash to build up your hosting infrastructure. And if you build too much capacity, you don't get an attack, then you basically wasted that cash, or you bought an expensive insurance policy that you never cashed in, right? Or if you don't buy enough capacity and you count only on having over provisioning, that attack grows, it's bigger than your capacity, and you take an outage. And so all of that like spend for capacity that you had just didn't really matter. Okay. So being able to understand what your capacity planning is has to go or goes a long way in understanding how much over provisioning you have to actually have. Okay. But most people, they will over provision at least to a particular amount, and then they'll use other solutions to compensate. Okay. Moving on now, the next one is mitigation appliances. Straight up Arbor Kit, Radware Kit. They're the 2 biggest vendors that are out there. There are a couple others. Some network devices have those, but overly simplified, these are stateless IDS that recognizes the patterns of DDoS attacks. And so what you'll do is you'll go here to your upstream from your firewalls. You'll put in your mitigation appliances, or usually an array of mitigation appliances, and they will detect and block DDoS traffic, or they'll drop it, right? More advanced version, you buy your appliances and you put them inside of the ISP immediately upstream of your circuits. Okay. But those are for folks that have big infrastructure. So the big FSIs, they'll have some kind of on-premises appliances that they put in there, and they will detect and block traffic. Okay. The pluses, number one, it happens inside of your data center, so you can control it. They also do monitoring. So they'll do monitoring either natively, or they'll be able to provide flow, various versions of flow out to other solutions. The minuses there, so they're not cloud compatible. They a lot of times you buy the boxes, but you need operators to use those. And because of the cyclic nature of DDoS attacks, the operators a lot of times don't know how to operate the kit, so they try to simplify the interfaces. There's training, like any other technology solution. You have to train folks up on how to use them. When they work absolutely great. Okay, but the biggest problem with appliances is that you still have the circuits coming from the carrier or from your ISP, and those have a limitation in how much bandwidth can come across. Okay. Next one. So obviously you want more capacity. So you go to the ISP and you can get a contract from the ISP for DDoS mitigation. And what happens is that the ISP goes to where they peer with other ISPs, and off to the side of that, they build a scrubbing center. They use a lot of the same on-premises appliances, right? So there's Arbor, there's Radware. They build that out. They build out a scrubbing center, and then they can route that traffic either by network block or by individual host, /32 IP address. They can route that through the scrubber. The clean traffic is returned into the core of the network, and then they forward that traffic on to you as their customer. Okay. It's really good for small to medium-sized websites. It's really good to complement maybe on-premises appliances. You just get more capacity and a certain amount of compatibility there. Okay. The downside, though, is that you have to have a DDoS mitigation contract with all of the ISPs that carry traffic for you. Okay, so if you got 5 ISPs, you have to have 5 contracts with them, because if you have attack traffic coming from one ISP that isn't mitigated, it's still, you end up over capacity in the data center. Okay, so that's a problem. Each additional ISP that you add into the mix adds extra cost for you. The ISPs themselves have peering that they have to protect. And so if the attack gets above the capacity that they have with their peering or their connections to other ISPs, then they will end up black holing your traffic, simply because they have to protect this quality of service to their other customers. Okay, but I've got some numbers. Normally, the ISPs will have 20 to 120 gigabits of mitigation capacity, which is still pretty good, right? 120 gigabits per second of mitigation capacity is still pretty good for 99% of the attacks that are out there. Some of the extremely bigger ones, it's not enough, and so they will actually black hole your traffic, and we'll talk about black holing here at the end. Okay. Then you have a third-party cloud scrubber. What you do is you contract with the folks that operate a dedicated scrubbing center. Really, you do that for the capacity. And the way that these work is the vendor operates their scrubbing center. You make a GRE tunnel. So you have this encapsulated tunnel from your routers out to the back of the scrubbing center. You advertise your route to the scrubbing center via BGP to the front of the scrubbing center. They take on your traffic, they clean it up, and then they send that clean traffic back through through that GRE tunnel. Okay. Really good for the biggest attacks. This is where you get the second biggest bandwidth available, in that, like, our scrubber is 15 terabits per second. There's another one that's out there that's comparable in size. Those are the two biggest that I know of. There are a couple others that are out there that are reasonably smaller. They're in between 5 and 10 terabits per second, but you have a lot more capacity for network traffic. The downside to this approach is that you have to be able to play BGP. So you have to be able to do a GRE tunnel. You have to be able to, well, let me flip here. You have to be able to play BGP. So you need a whole network block. So /24 or bigger network block. You need an ASN. You need to be routing traffic with BGP. You basically have to be, run your own network. There's a variation that the scrubbing centers use, where they have an IP address that they own that does like a NAT and then returns the traffic to you across the internet, so you can switch individual host names over to it. Okay, but if somebody attacks other targets inside of that same network block that service is hosted on, it'll still cause an outage for that service. Okay. So the biggest one is just the biggest downside to scrubbers is just setting it up and meeting the technical prerequisites. Okay. Maybe a secondary minus is going to be in latency for the user to the scrubbing center and then back out to the data center. Okay. So there's a whole story on how we actually prepare for that and reduce the latency for the scrubbing center. Okay. That brings us to the fifth one, which is a web application firewall or cloud-hosted web application firewall. And in a CloudWAF, what happens is you go in and you take DNS and you take the A record for that particular host name and you point it at an IP address, or sometimes you CNAME, which is like a DNS redirect, for lack of a better word. It's a pointer to another host name, and then that host name has a has an availability pool. But anyway, you use DNS to direct the end user to an IP address owned by the CloudWAF. They usually have a TLS certificate that's there, right? Especially since now everybody's doing TLS. So they have a TLS certificate that's there. That end user negotiates TLS with the WAF, sends their HTTP request across. That WAF inspects that particular request. If it's harmless or benign, it forwards it on to that authoritative web server, right? And so you have to go set up what host name you want, and what your backend or your origin web server is, right? So it'll forward it. The web server will create a response, reply to that web server, and the web server forwards the response on to the end user. Okay. So folks that are out there in this space, you've got the big CDNs. So you've got Akamai, Fastly, Cloudflare fits in here. My company has a cloud-based web application firewall. There are a couple others out there. So Imperva has something like that. F5 has Silverline, but this is kind of a crowded space. But it's really good if the target is a website. Okay, that's the biggest plus for CloudWAFs are they're really good for protecting websites. They drop a lot of traffic natively because that attack traffic isn't proxy safe. So it's not HTTP, so they just drop it. Have a nice day. And then you can add other features in there. This is kind of an eyeball chart of slide. They added a bunch of other features in there like caching on the WAF. So that way you can get a lot of offload off your website. Okay. The minuses, the biggest one is that they only protect websites, web applications, and usually only on TCP 80 and 443. Okay. Another downside is that you have to put TLS certificates there on that on the CloudWAF. So some people have to get over their security objections or risk management, and then the last one is what we used to call direct to origin attack, where if you know, so if you look back here, you know where this web server, the authoritative web server is, and you know what IP address it is on, you can attack it directly and cause an outage. So a lot of the providers now provide you a list of IP addresses that are these servers here that they will use those IP addresses or network blocks in order to pull content from your authoritative server. That way you can go to your ISP and ACL out everybody else and only allow that CloudWAF to pull, to make requests. So question from Sam Wong, any reason you couldn't use a WAF for quick traffic? No, they just have to support it. It is no, they just have to support it as a proxy. Okay, it's really a distributed reverse web proxy with the filtering rules applied over the top of it. Okay. All right. And then the last technology/technique is remotely triggered black hole. And in remotely triggered black hole, what you do is all of the ISPs around the world have the RFC 1918 address space. So 192.168, 10.0.0, 172.16, 127.00, whatever. They have all of those set up to be routed to the null interface on the router. And with remotely triggered black hole, what you do is you basically come out and say, hey, you know what? The route to get to my network block is through one of these RFC 1918 addresses spaces. Okay. you typically through 192.168 dot something, right? And all of the routers of the world, once the BGP update goes out, they all start directing that traffic to that that private address space, and all of the routers just start dropping that traffic. Right? Believe it or not, this is used a lot where it's just not cost effective to mitigate the attack. Okay? You can use it in conjunction with something like communities. So when I lived in Singapore, all of the ISPs inside of Singapore had a community. They would use private routing internally to get to each other. And then when they black holed traffic, they would push those routes outside of the country, outside of the internet exchange point, and drop all the internet traffic and keep the local traffic being delivered. So it's not as bad as it might sound. Yes, it causes an outage, but it causes an outage, but only in places where the BGP propagates, which is most places, right? But there are ways to mitigate in and around that. This is also what ISPs will do when they are overwhelmed with traffic for a particular customer, and it starts to threaten their peering. They will actually use remotely triggered black hole to start blocking all that traffic in other places. Okay, they have other tools that they can use, but everybody else has to have the same tools. So they'll use the remotely triggered black hole for a lot of stuff because it's effective at stopping the traffic near its source. Okay, I've got a summary there, little bit of an eye chart. Really, each one of these technologies or architectures has positive points and it has negative points, right? And it's whether is it on premises and you got one set of problems, or is it cloud-based, you've got another set of problems. How much is the maximum capacity that the solution has? But also ask, because different providers have different capacity. And then kind of what's the best use for it, right? And of course, like everything, everybody else wants to know what's the best technology, right? And you get the security guy answer. It depends, right? They're different tools for different purposes. And so that it depends comes down to, what is it that you're trying to protect? Are you trying to protect a website? Are you trying to protect VPN concentrators? Are you trying to protect DNS servers? Are you trying to protect SMTP servers? Right? So what's the target, or what is the asset that you're trying to protect? That's the first question, right? And then pick, where is it? Or pick what's the right technology or a set of technologies for that. You might also ask, where is it located, right? Is it on premises? Is it cloud-based? Is it a third-party provider? The second one, understanding attack trends. Is anybody attacking your industry, your peers by industry, by country, by size? Okay. Number three, protection levels. So what do you have already that you can use? Maybe you've got a CDN and you need to turn on CloudWAF. Maybe you've got some on-premises kit that maybe you need to plus it up a little bit, but then turn on the DDoS mitigation aspects of it. Okay. The consequences and cost, right? So look at what is the total cost of downtime for you, and then budget according to what that cost is. The effects of DDoS attacks. I love this bottom one, but one of the little secrets of the DDoS world is that attackers will throw volume at you in order to get you to turn off some of your boundary protection. Right? That way they can steal data or do defacements or exfiltrate or whatever it is that they're going to do, or to burn out your response staff. Okay. And then the last one is, how much does that particular technology solution cost? And do you get other benefits out of it that could help with other problems, right? Like over-provisioning could help with other things, right? That helps you to scale if you know that your web traffic is growing, okay? The reality is that people that are out there that are defending against DDoS successfully are using multiple technologies, multiple architectures together in order to balance out the positives and negatives of each solution. Okay. I have a couple examples there, like a large scale web native company. So they'll use the third party scrubber, the dedicated DDoS scrubber. They'll own their own network blocks so they can do BGP. They'll use CloudWAF for their big flagship websites because they also get some kind of caching and delivery, and they get protection against web application attacks. So they run WAF, right? And then they'll use a DNS provider in order to be able to get some performance gain in DNS queries. But also they know that that's just a massively scaled DNS infrastructure. Okay. But they'll have a strategy. They'll set priorities. They'll determine this is the target type. Here's what my strategy is. Okay. Monitoring is a big thing. So you can monitor yourself with, just simple network monitoring tools, monitoring from your routers. Some of the DDoS appliances will do monitoring for you. We'll do monitoring as a service. We have that. Sometimes your ISP will do monitoring as a service for you, at least to be able to detect, big traffic spikes. You have some kind of gating criteria for on-demand. So where the solution is out of band, you have some threshold at which you say, you know what, this attack is big enough, it's long enough, let's flip it to mitigation. And then you have to test your solution, especially if you don't turn it on very frequently. You need to test it to make sure that it's still configured to work and that your staff still have the knowledge in order to use it. Okay, there I am. Now, questions here. Questions, starting at the bottom. If my website is hosted on Webflow and my domain is on a Google domain, will the DDoS affect Webflow or Google? It could be both. It could be both, right? And you see this with attackers. They will come in and they'll start with www and they'll start trying to flood out the they target by IP address. They'll try to flood out whatever host www resolves to. Might be multiple IP addresses if you're using load balancing, right? But they'll try to flood that out with network traffic. That doesn't work, say. So then they'll switch to sending HTTP. So they'll send fully formed spec compliant HTTP requests. Maybe they'll get that to cause an outage. Maybe they won't. That doesn't work. Then they'll switch to, let's go attack DNS. That doesn't work. Then they'll switch to a bigger botnet. So everything in the DDoS world is a dependency chain, right? DNS makes everything work. So that gets targeted frequently. Websites get targeted quite frequently because that is that's your presence. That's your underlying presence. So they'll attack www or whatever the website is. They'll attack that directly. Okay. Then they might attack other hosts that are inside that same network block. So there's a lot of it depends there. But yes, does the DDoS affect Webflow or Google? Yes, probably impacts both of those. Okay, depending on how much they hate you and how many resources that they have available. Okay, quick, I answered. Network resiliency with ISPs and DDoS attacks. I think I covered that. Are you still okay with that, Jason? All righty. Any other questions? If not, then let's see. Okay. Oh, Sam's getting crazy on me. SDN Does SDN change the available controls? It gets different. Okay. It gets different. So this the DDoS mitigation scrubbers on the back end, they could peer into what, for a very layman's definition of peer, they could peer into SDN, right? And SDN might be the way to return that clean traffic. It could be a way to balance across multiple ISPs. There are a bunch of different things that SDN allows us to do from the mitigation solution back to the data center. That's cool. It also helps us on the service provider side to be able to load balance on the front of our solution. That's good. It just provides a different set of capabilities, right? I think you just have to look at each feature and go through and kind of figure out how it would help or hinder. Nobody that I know of has started to attack the control planes for SDN. And that's kind of a thing. But I think anything in flexibility of how you manage networks gives you an advantage in managing either the on-ramp to mitigation or the returning clean traffic back to where it needs to go. Okay. Having said all that, thanks, folks. If you still have questions, I'll hang out here for just a little bit, but I shall see you all later.